So we're going to do some problems with inscribed angles. So a couple notes I have up here on my page: all my arcs sum to 360, all my central angles sum to 360. One other thing to remember is that an inscribed angle is half of the angle or of the arc it opens up to. So we call that an intercepted arc. So this is sort of an important thing to remember here. Let's just put it in a nice red color. So we'll go through that and what that means on a couple of these examples. So let's do it. Now, don't get scared by these pictures. They're a little sometimes confusing, but it tells you here that ABC is equal to 40 degrees. So that's this arc right here. So we know that ABC, this angle is equal to 40, which means that arc AC is equal to 40. So if that's equal to 40, then this angle way down here, this angle ADC, this orange angle, because it also opens up to this arc, it's half as much as that. So we know that these angles are half as big as the arc they open up to. So that angle, ADC, should be half of that arc, 40. So half of 40, which is 20. So here we've got a very similar picture. It tells us ADC measures 20. So they're giving that to us now. And it's asking you for what AC measures. So this is just going in the opposite direction. So if you have this angle down here and it's 20, and you know it opens up to this arc, you multiply by 2. So I should be able to do 20 times 2. And that's equal to 40. Okay, a little picture here that maybe is a little bit more confusing, so we'll try this. So it says ABC measures 122. What does ADC measure? So ABC is this arc right here in the center, this angle right here in the center, and it means that this arc also is 122. So an angle in the center and the arc it opens up to are always going to be the same. So I know that AC is 122. So I should be able to draw on this for you. So again, when you look at what this opens up to, if you extend this angle, this arc right here is what is 122. So this angle down here that we're looking for, this angle right here, that should be half as much as 122. Because again, if you look at this angle, it opens up to this arc, which is 122. I should be able to cut that in half and figure out what this angle is. And again, if you just follow that arc back down to your angle, that angle is half as much as that arc of 122. So if I come over here to my calculator, 122 divided by 2, I end up with 61. So that should be 61 degrees. Sometimes the pictures can get confusing, but try not to let that distract you here. So, last question, circle is centered at point B. A, D, and C lie on the circumference. That information is just making sure that you know they're on the circle. It says ADC measures 35. ADC. So this angle right here is what your 35 is. And what does ABC measure? So ABC is this one right here. So that's what I'm trying to find. Now, let's find some information based on what I have. So this angle CDA is 35. The arc that it opens up to must be twice as much as that. So if I come out here from 35 and I extend my angle out, it intercepts this arc right here. So this arc right here should be 35 times 2. Well, that was pretty bad. We'll just undo that. So this arc right here is 35 times 2. Now I know 35 times 2 is 70. You can always use your calculator. So that's 70. Now remember that when you have an arc, any angle that opens up to that arc in the center is exactly the same. So if this is 70 right here, this angle, I know that this angle right here in the center is also 70 because it's a central angle. So that would also be 70. Now before I enter, I just want to show one more part of this example. if you were to take this arc and you were to make an angle down here that opens up to that arc, if this is 70, this would also be 35. So anytime you have an angle that's on the circle that opens up to an arc, you just divide by 2. And that's kind of the whole idea behind inscribed angles.